previous video, we looked at how to factor perfect square trinomials, and also how to multiply out perfect squares too. So for example, here we are creating some perfect square polynomials by squaring these binomials here, and here are our results. So all of these answers over here, all of these standard form answers, these are all perfect squares. Okay, so if we know we have a perfect square, we can use some of our shortcuts to then get the factored form. Here in our table, right, we had a bunch of perfect square polynomials. We were told that they were perfect squares, and so to factor them, we could use our shortcuts, right? Square root the c term, halve the b term, right? So square root of that gives you 6, half the b term gives you the 6 there too, okay? So we end up with just x plus x squared. And the same thing we could do for all these other ones as well. However, when we got to this problem, we ran into a situation because this is not a perfect square. Okay, first of all, you can't nicely square root 3, it just gives you square root of 3, right? And then half of 8 is 4, so those numbers don't match up. So what do we do here? Well, we have to do some adjustment, and this is where the idea of completing the square comes in, because right now, that 3 is not a perfect square, and so that makes this whole thing not a perfect square too. Okay, but furthermore, we can't just make any perfect square here, right? So let's what we're going to do here. This 3 is kind of throwing us off, so it's not a perfect square. So let's just go ahead. I'm going to kind of move this 3 out and leave some space. We're going to kind of create two separate problems here. Okay, I'm going to break up this plus 3 over to here. So let's try and fix this so that we can actually, factor it. Okay, like a perfect square. So if this thing is going to factor, we'd have an x and an x just like this. And if we want it to be a perfect square, that means these two things would have to be exactly the same. Okay, now whatever number goes here, it will multiply with this x. And whatever number goes here will multiply with this x. And together they're going to add up to make 8. So these two numbers have to add to make this 8 here, but they also need to be the same number, so we create perfect square here and here, right? So they have the same factor. So what two numbers are the same and add to make 8? And the answer is 4 and 4. Okay? So this is going to be our perfect square, x plus 4 squared. But the problem is, what number needs to be here? Right? The x and the x, that'll make the x squared there. The 4x and this 4x will make this 8x right here. What's the 4 times the 4 going to make? A 16. Well, we don't have a 16 in here. Can I just add a 16 in? Well, the answer is yes, kind of. So if we just add a 16 in, we're now changing the value of the problem. But if I simultaneously subtract a 16 over here, now what have I really added? If I add and subtract 16 at the same time, what value have I really added? I've added 0, okay? And so that's what we're doing here. We're going to, quote, add 0, but we're going to do it in such a way that it creates this perfect square right here. So what do we do with these numbers out here? Well, we just combine them. So 3 minus 16 will be negative 13. And we just bring that along for the ride. And so there is the equivalent expression. This is equal to x squared plus 8x plus 3. These two things are the same. But we were able to do it using a perfect square. Okay? In the next video, we'll do some practice here with these. In fact, yeah, we'll see you next video.